Work is one of the most fundamental physics concepts tested on the MCAT, especially in the chemistry and physics section. But here's where students get tripped up. It's not about how hard something feels, it's about how force and displacement line up. The exam will throw equations, graphs, and even conceptual setups at you. And if you don't have a rock-solid grasp of what counts as work, it's easy to overthink. So let's cut straight to the essentials. What work really means. In physics, work happens when a force causes an object to move in the direction of that force. No displacement, no work. Holding a heavy box still might feel like effort, but on the MCAT, that's zero work. The formula. Work is calculated as the dot product of force and displacement. Work equals force times displacement times the cosine of the angle between them. When force and motion are aligned, work is positive. Push a box forward, that's positive work. If the force opposes motion, like friction, that's negative work. Work energy principle. One of the highest yield takeaways, the work done on an object equals the change in its kinetic energy. This means whenever you see work in a problem, think energy transfer. Conservation of mechanical energy. If only conservative forces, like gravity or spring force, are acting, total mechanical energy stays constant. But if non-conservative forces like friction or air resistance come into play, they steal energy from the system. That's why the equation becomes initial kinetic energy plus initial potential energy plus work done by other forces equals final kinetic energy plus final potential energy. Positive versus negative work. It's worth repeating. Positive work adds energy to a system, negative work takes it away. That's the MCAT's way of checking if you really get how energy shifts in different scenarios. Net work. When multiple forces act, the total work is just the sum of all contributions. If tension, gravity, and friction are all at play, add them up to find the net effect. Variable forces. Sometimes force isn't constant. In those cases, work is the area under a force versus displacement graph, or mathematically, the integral of the force dx. The MCAT doesn't make you calculate messy integrals, but you need to recognize that the concept connects directly to energy transfer. Units. Work is measured in joules, the same as energy. 1 joule equals 1 Newton meter. That's the MCAT's way of reminding you. Work and energy are two sides of the same coin. So here's the big picture. Work isn't about effort, it's about energy transfer. If you can connect force, displacement, and energy, and recognize when forces are positive, negative, or dissipating energy, you'll unlock a lot of points in the physics section. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.